Give them a little kiss and goodbye. I'll see you soon. Let's get going. All right. So today is about reviewing exponent laws, which you did. Okay. Let's remember what they are called as well. So we're going to start off. So the reason why I did what we did just now is because often students memorize the exponent laws. They're like, when you multiply x's, you add the exponents, right? What I wanted to do right now today is to remind us why it is that we add the exponents, right? When we're dividing, why is it that we're subtracting the exponents? So, because that's important to have that understanding. So our first exponent law that we looked at was the exponent law for multiplication. And so when we multiply, so first of all, let's remind ourselves of the terminology. So this little thing is called what? That's right. What is this thing called? You got it. Okay. And if I chose some really great colors. If I have something like this, what do I call that 3? Wow. Did you study this last night?
Yeah.
Obviously. Good for you. Okay, so these are some terms. Remember, on the test, when we have communication questions, I'm looking for the proper terms, right? So we're making a list of terms, and when I study for a test, I make sure to review those terms, right? All right, so in the first law of exponents, this is about multiplication. And what we found is when we are multiplying two identical bases, we add up the exponents, right? So if I have x to the power of y times x to the power of z, right? So here we're making a general statement. How would I write that? How do I summarize this? Oh, wait, that looks like a 2. Maybe make that a z like that. The general statement would be x to the power of y plus z. Does that make sense? I know I'm using variables instead of numbers, which you are more comfortable with, but this is sort of how we make a generalized statement. Okay, is that good? All right, similarly, the exponent law for division tells us that when we have y to the power of w over y to the power of x, what will be the generalized statement? So we're dividing identical bases. Who can tell me what I would write here? Actually, don't tell me. Tell the person you're sitting next to. Okay. Do you agree with me? Y to the power of w minus x? So we're subtracting the numbers now. Okay, the exponents. Great. Okay, let's move on to the power law. So this is when you have a power to a power, an exponent to an exponent. Okay, so if you have an exponent and a second exponent, what is it that we do with those two exponents? We multiply them, right? And we broke it down by saying, oh, this is 5 squared times 5 squared times 5 squared, and I know that I can add up these exponents. So if I have x to the power of w all to the power of y, the generalized statement, okay, again, either write it down or tell the person you're sitting next to what you think it will be. Luke, any idea? Great. Here? No, because so Luke had a good question. He said, didn't we just say it here? And actually, we didn't, because this states x to the power of w all to the power of y. This bracket does not imply multiplication, but as a result, we are multiplying. Okay, now, folks, did I need to draw that little dot there? Right? I could write x to the power of yw, right? Or wy. When we have two variables right next to each other, it implies that they're being multiplied. Okay, moving on. So now we have a law that we did not learn in grade 9, but it's called the power of a product. Okay, so this might be a little bit new. So when we have a product, when we have two terms that are being multiplied, okay, put that phone away, and the entire bracket is raised to a power, right? It means we're multiplying it 3 times. Now, the important thing is that inside the bracket is a product. Product means multiply. Okay, what that means, once we reorder all the 5s and all the 2s, we see, oh, the exponent is just applied to each of the terms. This is not true. Okay, I cannot say this. Okay, this might be a common mistake. Do you see the difference here? Okay, person who is sitting closer to the window, I want you to tell your partner why this would be a mistake. Lila, why don't you turn around and tell Elian why it would be a mistake? And we got some, yeah, Victoria, you're jumping in there. Luke, turn around. Sebastian, you can turn around, listen to that conversation. Luke, do you guys got it? Yeah. All right. Time. So are we good? So why is it, who can tell me why this is okay and this is not okay? Polly, what did you folks think?
I mean, I didn't really get it, but maybe there's 2 3s.
Like this?
Yeah.
Okay, so why can I do this, but I can't do this? That's it. This is a product. What do we call it when we're adding 2 things? Okay, this is not the power of a sum rule. This is the power of a product rule. So when you are multiplying 2 terms and they are all raised to an exponent, you can distribute the exponent to each of the terms. So let's generalize that. X plus y to the power of z. Okay. Oh, sorry. Whoa, Miss Sly. Whew. X times y to the power of z. Go ahead and write down how we can simplify this. What is it, Kajik?
It's x to the power of z minus y to the power of z.
Good. So let's just take a moment to do an example here. Okay, I'd like you to apply. Let's have everyone work on this example here. And do notice there's a negative, and I put that there on purpose. And I'm going to make a mistake for you guys.
See, it will change what it's like, depending on. No.
No, it's only for X.
I've made a mistake. Does anyone see my mistake? Luke does. Anyone else see my mistake? Yeah? Timo, do you see it? It's kind of careless. What's my mistake, Annabelle? Why? Folks, what is the answer to -2 squared? No. It's -4. What is the answer to -2 squared? 4. Because, watch this. This tells me -2 times -2, where this is saying -2 times 2. Because the negative sign is not under the power. Do you see that? So you must include brackets. In here, this -2 is all being raised to the power of 2. So I must include brackets. And so as a result, I get 4x to the power of 6. Again, this is a common mistake or a common misunderstanding, right? And we love learning mistakes. All right, let's go to the power of a quotient. Liam, what does quotient mean?
Division.
Like, do you read math books at home?
Yeah, it's what I do for fun.
You do. I thought so. Yeah. Quotient means division. Usually in the form of a fraction. Okay. Now, if you are not like Liam, like if you don't sit at home in the evening and read math books, you might want to be building a word bank so that these terms are familiar and you start being comfortable using them. All right. So in here, we have a quotient or a fraction raised to an exponent, right? And we see, we just write it out 3 times. And that essentially means 2 to the power of 3 and 5 to the power of 3. Yeah. And so what we're saying here is if I have x over y to the power of w, can you simplify? Can you remove the brackets? Timur, can you see the board? Would you like me to turn it a little more? Sebastian, you can see it? Yeah, Marley, you can see it?
Yeah.
Okay. Who wants to be bugged? All right, no one wants to be bugged. Greg, do you want to tell me what you think we would get here?
X to the power of W over Y to the power of W.
Great. So this quotient law is very similar to which other law? Which one is it? Like the same? Yeah, Sebastian? It's the power, right? Because multiplication and division are opposite operations. And so that means whatever we do for a product, we kind of do the opposite for a quotient, right? So we see they're related. Okay. All right. Next one is the 0 exponent. Folks, what is Miss Sly to the power of 0? It is. Right? What is math is fun to the power of 0? 1. Okay? Always. And here we see that because if I have 2 to the power of 3, Let's expand that. Well, that's just saying 2 times 2 times 2. And in the denominator, so I can cancel out pairs. Now, as I'm canceling them, I'm actually, in theory, saying, okay, I'm reducing this to a 1 and a 1, and 1 and 1 and 1 and 1, right? I'm saying, oh, I'm dividing 2 and 2 by 2. So that reduces to 1 over 1. So in theory, I have a fraction that says 1 times 1 times 1. 1 times 1 times 1, right? So usually when we cancel, we don't add a 1 there, but we assume that it is there. So as a result, I have 1 over 1, okay, or just 1. And if you forget this, you can always plug in any exponent to the power of 0 into your calculator, and you always get 1. Yeah, that's a great question. Try it out. That wouldn't make sense, right? That to me, try it. I'm actually curious. You tell me. So to simplify this, x to the power of 0, what is it? Uno. O then. That's it. Did you try it? No, I don't, because it's a 0, there is no value. Like I would think it's a 0. Yeah. All right, last one before we put this all together is a negative exponent. All right, so in this case, let's expand it. 2 to the power of 3, 2 times 2 times 2. 2 to the power of 5, 2 times 2 times 2 times 2 times 2. So let's remember, okay, I can cancel these. I can cancel this pair. I can cancel this pair. Now, what remains in the numerator? There is a 1. It's not 0, right? We have a 1 here. So what I end up with is a 1 over 2 times 2, which is 1 over 2 to the, let's not write 4. Let's just write 1 to the over 2 to the power of 2, because we want to see what's happening with the exponents. Now, if I just used the quotient law and I said, okay, that's going to be 3 minus 5, I would get 2 to the power of negative 2. Agreed? Well, what I'm seeing is when I have 2 to the power of negative 2, that also equals to 1 over 2 to the power of 2. So what does the negative tell me? Yeah. Yeah, we're going to the negative implies a reciprocal. Okay. So this tells me that x to the power of negative y is going to be equal to 1 over x to the power of y. But I want to do an example. I want to do 2. Okay, simplify that one. And here's another one. So let's look at the first example. Well, this negative is telling us to write the reciprocal. So watch this. There are multiple ways to approach this question. But if I want to really break it down, I'm saying, oh, I'm going to first get rid of the negative. So I have 3x to the power of 2, right? If I just want to get rid of that negative, I just write the reciprocal. And now I'm using the power law. So 3 squared, oh, that's 9, and x squared. Is there another way to do it? Yeah. -9. I don't think so. But I think okay. I can use the power of a product rule. Do you remember this one? So I can apply the power of a product rule first because this is a product. This is 3 times x. So alternatively, let's use a different color. Oh, this is nice. I could say, okay, so this is 3 to the power of -2 times x to the power of -2. Right? I can do that one as well. And 3 to the power of -2 is 1 over 9. X to the power of -2 is 1 over x squared. So you can sort of choose your own adventure, which ends up, because we're multiplying, we just multiply the denominators. I personally like to deal with the negative exponent first. So let's look at the second example. I have a negative exponent, but I'm also noticing that I've got the quotient rule. I could first work with the quotient rule, but I'm actually first going to work with the negative exponent. So that negative means I have to write the reciprocal, right? I'm going to write that word. Reciprocal. Add that to the list. And so in my first step, I am not calculating anything. I am going to rewrite this fraction as its reciprocal, all to the power of +3. So all I've done thus far is just eliminated the negative exponent. And from this point, oh, now I can use the quotient law. So what does the quotient law tell me to do? Well, it tells me to distribute the exponent of 3 to every single term. So I've got y cubed over 4 cubed over to the power of x squared cubed. Right, so I'm showing all the steps. You can definitely skip a few here. And so to simplify, we've got 3 cubed. Anyone know what 4 cubed is? Come on, you can do this. 4 times 4? Okay. 16 times 4. You can do it. Break it up into 10 times 4 and 6 times 4. What is it, Eloy? No? Oh, you went way too far. 4 to the power of 3. Yeah. Excellent. So, folks, use that brain of yours. And then x to the power of what? 6. Good, because now we're using the power law. All right. Let's look at 2 examples that are a bit more difficult, right? So this is a review of grade 9, a few new little bits. Let's bring it all together. Some fun stuff. Lewis, what's your favorite color? What kind of orange? Like what's orange? Sure. Darker orange? All right. This is like, I'm going to give you a good orange. All right. So let's look at this example. Many things happening. Okay. What do we want? We can have various approaches. Okay. I'm going to first deal with that negative on the outside. Oh gosh, but there's also negatives on the inside of the bracket. Fine, let's go inside. Okay. I think of bedmas, right? And I think bracket, which means what can I do inside the bracket? So for now, what I'm going to do is keep the outside to the power of -2. Whoa. And now I'm going to rewrite everything inside the bracket. If it has a negative exponent, I have to write the reciprocal of it. So watch here. If x to the power of -2 is in the numerator, I can easily get rid of that negative by just moving it to the denominator. Do you see that? Make sure you see what I just did. Okay, so this -2 just says, hey, just put me into the denominator. Okay. Well, the x to the power of 4 is a positive, so that stays in the denominator. The y to the power of 3 stays where it is. How about the y to the power of -3? Where do I write it? That's right, Astrid, up there, right? It becomes, I write the reciprocal. So this y to the power of -3 moves up to the numerator. So you don't have to be scared of those negatives. It just says, just flip it. Okay, can I do something else inside the bracket? Yes, we can. Which law am I doing? Or which rule? It's called the product rule. So the 4 and the 3, nothing changes. But now I've got two identical bases being multiplied, right? Y cubed times y cubed. What's that give me? Y to the power of? Yeah. How about the x? X to the power of? Yeah. Oh, this looks so much better, right? A bit of relief. So once I have simplified the inside of the bracket, now I apply the exponent on the outside of the bracket, right? Because you want to find the simplest, cleanest solution. All right. So I'm going to first take one step to just clear the negative. You can skip this step, but I won't. So this negative means that the entire fraction is written as its reciprocal. So in this step, all I did, right, to clear negative, so to clear the negative exponent, I'm going to write the fraction as its reciprocal. Okay, and now the last step for me is to apply the exponent. And this is two rules together. This is power of a quotient and power of a product. But basically, each component, each coefficient, and each variable get the exponent of 2. So I get 3 to the power of 2 over 4 to the power of 2. Yeah, I guess I'll show you the extra step. You don't have to show it. X6 to the power of 2. Y to the power of 6 of 2. Right? This is a skippable step, definitely. And to finish off, 3 squared, right? To fully simplify, it means to get rid of all exponents possible. 3 squared, 9. 4 squared, 16. X to the power of 12. Y to the power of 12. In these type of questions, we make a lot of silly mistakes, so it's important to practice. Any thoughts? Any thoughts? Why did I write a comma? That was hilarious, Greg. X, is y ever in the denominator? X comma y cannot equal to 0. That was worth it. All right, let's look at the next question. Okay. This one can be a bit tricky because anyone know what's the mistake that's going to happen? Okay, so let me show the mistake. Why is this a mistake? Why can I not do this? What is it? I got one person knows. 2 people. What do we think? What do we think? All right, Greg, why? Yeah, because of this thing. Because we are adding the terms in the numerator, I can't just flip restrictions. Okay? So this is a common mistake. Ooh, great. All right. So what can I simplify? Well, I know 3 to the power of 0 is 1. So let's see. I've got 4 to the power of negative 2 plus, actually, I might as well just write it as a fraction right away. 1 over 4 squared plus 1. Now watch this. We are dividing it by 1 over 4 to the power of 4. Sorry, that 4 is... Do you see what I did? I just took out that denominator. I said, well, it's the same thing as saying divided by. And because it's 4 to the power of negative 4, I write the reciprocal. Well, wait a second. We know what to do when we're dividing fractions or rational expressions. What do we do?
Flip.
That's right. So I've got 1 to the power of 4 squared plus 1. I'm not yet expanding anything, times 4 to the power of 4. Right? Is it okay that I got rid of the over 1? Yeah. Interesting. Before I'm simplifying, can I do something? Can I do that? Yeah, so watch here. So we've got 4 to the power of 4 times 1 over 4 squared plus 4 to the power of 4 times 1. Now, I have not calculated the exponent yet. I'm keeping it in exponent form for now. And I'll show you all the steps, but you can definitely cut some steps here. So I've got 4 to the power of 4 over 4 to the power of 2. I know how to simplify that. Plus 4 to the power of 4. So if I have a quotient, I'll subtract the exponents. So 4 squared plus 4 to the power of 4. And then at this point, we calculate. Okay? Folks, I'll finish this one example in the video for tomorrow.